this is a wave, correct? And what you have to know is, you have to know things like the wavelength, that's a lambda. The distance between two crests. It's the wavelength. Clear? Now this is all moving at the same speed. So the closer these wavefronts are, the greater the frequency. How do I know that? How do I know that? Because, and this is related to tomorrow's quiz, I know that the velocity of the sound is going to equal the product of the wavelength times the frequency. So as the wavelength becomes larger, as this number becomes large, what must happen to the frequency? It must become smaller. Clear? Yes? So if I want to calculate the frequency of a large wave, now here it's even clearer. As the wavelength increases, the frequency will decrease. You get that? So, let's do a calculation. If the frequency is 2 hertz and the wavelength is 10 meters, what's the speed? Simple. What's the speed? 20. Yes? Simple. Is that simple? Yes or no?
I said that was easy.
Yeah, that's it. You're just using this equation, and I'll put the equation on the board tomorrow. Right? It's easy. It's not hard. Here's another equation that I will put on the board tomorrow, and then we're pretty much done. Okay? And this is a little confusing. Okay? Period. What's the definition of a period? Thank you. What's the definition of a period?
It's a dot.
In terms of waves.
It's like a time lapse.
Period.
It's like the end of something.
No,
No.
it's
Then maybe the end of something.
the in between of something.
In between.
The period of a wave.
I think.
All right. You don't know. All right.
Yeah, we know.
That's okay. Let's look at frequency. You know that, right?
Yeah.
Yes?
It's a pitch.
That's pitch, good. Or waves per second, right? In other words, waves per time, right? So the waves per 1 second, right? Easy? Make sense? Is that okay?
Yep.
Yes? The period is 1 over the frequency. So therefore, it's going to be the time over the waves. Yes? So you could say the frequency is the waves per 1 second. Correct? The period is the waves, the time for 1 wave. You get it? What was the time for 1 wave? All right, the frequency of the waves is 2 waves per second. Okay? 2 waves every second, 2 waves. How long does it take for 1 wave?
2.5
No.
seconds.
Say
0.5. No, I didn't say that. You're not listening.
What do you say?
I'm saying to you that the frequency of the movement of waves is, past this point, 2 waves for every second. Every second, 2 waves will pass. I'm asking you, okay, if 2 waves per second pass by, how much time for 1 wave?
0.5 seconds.
0.5 seconds. Okay? Let's see if that works. Okay? The period equals 1 over the frequency, right? Yes? Okay? So, if the period, and I know that it's 2 hertz, 2 waves, we'll say, per 1 second. What's the reverse?
1 divided by 1 over 2.
Yeah, the reverse would be this. So it would be not this, it would be the time for 1 wave, which would be 0.5 waves per 1 second. You get it? Yes? You get it?
Yes.
The question is, the frequency is 2 waves per second. So, if it's 2 waves per second, okay, how long for 1 wave? Well, half a second. You okay with that?
You wrote.
Okay? The symbol for period is T, capital T. So, what you have is, you ready?
You wrote half a wave for 1 second.
Here, 0.5 over 1. A half a wave.
So half a
Oh,
second.
well, yeah, sorry. No, sorry, this is the time. Sorry, my apologies. Thank you, Zaytun. Thank you. This is the time, 0.5 seconds. Thank you, Zaytun. 0.5 seconds for 1 wave. Thank you. Thank you. You get that? I made a mistake. I apologize. Thank you, Zaytun. You get it? You get it? So the frequency equals 2 waves per 1 second. The period, T is the period, would be the time, 0.5 seconds per 1 wave. Right? So the frequency is per second. Right? The number of waves per second. Yes? The period is the time per wave, per 1 wave. Okay? So, frequency equals 1 over the period, and the period equals 1 over the frequency. That's it. That's your quiz. That's your quiz. There was one more question that we did yesterday. Remember, I was on the floor making a wave that was just like not changing really, right? So what kind of wave is that called? That was called a standing wave. So you got to know what the definition of a standing wave is. So look that up. Now, what I'll do tomorrow after the quiz, I'll redo the demonstration because it just didn't film well. I'm going to have someone hold it. I'm going to have someone hold. Thank you. You're wonderful. Thank you. I don't have people coming to give me these things. I don't deserve it. Okay? Thank you. All right? So do you get it? You understand? Any questions? You okay? So tomorrow, after the quiz, we'll go up maybe outside here, and we'll film the demos, okay? And I'll talk. Because I couldn't use the video. Wait a second. So let's review. Destructive and constructive interference. The Doppler effect,
The bug.
right? Sound is longitudinal waves. Light is transverse waves. What's the source of all waves? The name of chapter 25, it's in there. Vibrations. Either at the atomic level or playing the notes, hitting a drum. The source of all waves is actually vibrations. You got to know wavelength. You got to know the relationship between frequency and period, and between period and frequency.
What's the relationship?
What's the relationship? It's right here. That frequency is the reciprocal of period, and period is the reciprocal of frequency. Clear?
Alright.
And you have to know and you had some of this in chemistry, I mean, very little, I mean, a little bit of it. You know, we did lights, and there's so, I mean, it's part of, chapter 25 is both sound and light. At your quiz tomorrow. Both, right? 26 is sound. 27 is light. You okay with that? Okay. And I think that is it. I took notes. I read through the quiz and took notes. Okay? All right? That's it.